Sine, cosine is very nice. So I can see the sub right here because I know what the derivative of sine is cosine, right? So I see cosine dx. If I let u equal to sine x, then I will have du is cosine x dx already. Even better than that, because this is a constant, I can even let this is u equal to 1 minus sine x. Then I can substitute the whole denominator by one letter, and my fraction is going to be simpler. And du now will become derivative 1 is 0, derivative sine is cosine, so negative cosine x dx. See? Now this one will become cosine x dx is negative du, that's over u, is ln. Negative ln of u, which is negative ln of 1 minus sine x. And then plus c. Right, one line. You see the right method, and calculation shouldn't be too hard. Let me choose another one. Oh, I see this. Integral 1 over x cubed square root of x squared plus 1. Oops, sorry. That's x squared minus 1 dx. Alright, so I see another fraction. And now what? I have x cubed in here and then square root of x squared plus 1. You see that radical? Give me a hint of doing what? What is it called? Tricks up, right? If I let x equal to secant theta, and it's going to be secant square minus 1, it's going to be tangent. See how it goes, okay? At least we have a method. And again, I try to avoid trick sub as much as I can. So I think that I will do u sub, but let's just go in a natural way that you guys can think of. Let's do the trick sub. X equal to secant theta. The reason is tangent square theta plus 1 equal to secant square theta, or tangent square theta is secant square plus 1 minus 1. Okay, so I've got secant square minus 1 right here, which is tangent. X is secant theta, so dx is secant theta, tangent theta, d theta. Okay, so this integral will become this 1 right here, right? Dx is secant theta, tangent theta, d theta, and the bottom is x cubed. X cubed is going to be secant cubed theta, and x squared plus 1 is secant square minus 1. I mean, secant square minus 1 is tangent square. Square root of tangent square is just tangent. Oh boy, it's word. So tangent cancel out. This is integral of 1 over secant square theta d theta, which is integral of cosine square theta d theta. And you know this, I know for sure I can solve problem already, because cosine square I can use the double angle formula. It's 1 plus cosine of 2 theta and over 2 and d theta, and I'll leave you work the rest of the problem right there. Tricks up would work. Okay, but to be honest with you, when I see this problem, I was stubborn and I try not to use tricks up. I can do u sub in here if I let u equal to square root of x squared minus 1. I'll just try it, okay? It may be right, maybe wrong, who knows, but whenever we see a problem, it's worth a try. Let's see what I got in here. So u squared is x squared minus 1 square both sides. So 2u du is 2x dx. So cancel out the 2u du equal to x dx. Okay, so how do I modify my fraction? So I got x dx. I got 1 right here, right? So I can rewrite it. X over x to the 4 square root of x squared minus 1 dx. You guys see what I've done? I multiply the top and the bottom by x, so I got x dx. Okay, so my x dx is just u du. I got u du on top. Okay, what about the bottom? X to the 4th, I can think of x to the 4th is x squared, right? And x squared is u squared plus 1. X squared is equal to u squared plus 1. So this is u squared plus 1 squared for x to the 4th. U squared plus 1 squared. And then square root of x squared minus 1 is u. That's works too. Just fine. this is what integral, u cancel out, I got du over u squared plus 1 squared. Now what? We have to let u equal to, I think secant theta. No, tangent theta. I cannot avoid trig sum anyway. So this method is not better than the first one at all. It's actually slow. So stick with the previous method I showed you. It's going to be quicker. Okay? It's a lot of work. And then still go back to trig sum. Just can't avoid it. Okay? Just pick another one. I don't know. I was gonna pick this one, but this, I think it's easy. See it right away. Looks hard. Integral of x, secant x, tangent x, dx. Right? We have what? X right here, and we have trig right there, but secant x, tangent x, dx is a derivative of something. It's the derivative of secant, right? Secant x derivative is secant tangent. And we have two types of function in here. The polynomial times the trig. So most likely we think of integration by part. So if I let u equal to x, this is my u right here. This is my dv right here. You see, this dv, so v is secant, right? So u is x, dv is secant x, tangent x, df. So du is just dx derivative, and then v is secant x. So integral of u dv is equal to integral of u times v minus the integral of v du. So u times v is x times secant x minus the integral of v du. So secant x dx. It's a good example. Why? Because I see that integral, but I don't know how, right? So I know that we have a formula for this. We can look for it. I think it's ln something. Yeah. X secant x minus, I think it's ln of secant x plus tangent x, yeah. Then plus c, derivative. Okay. I think last week in the video clip, I showed you the formula for this integral of secant is ln of secant plus tangent. Okay? And we have the answer. Okay? Let's try one more. Then we stop our video clip. Just a bunch of them, so I don't know which one to start. Okay? Integral, some exponential thing, e to the 3 over x, and then over x squared dx. See this problem, I can tell you that I'll do a u sub right away. You know why? Because this is what let's say 1 over x or 3 over x, right? X on the bottom. Take the derivative, you're going to have the bottom right here. 1 over x, which is x to the negative 1, right? And the derivative is, the derivative of x to the negative 1 is negative x to the negative 2, which is negative 1 over x squared, you see? The derivative of 1 over x is going to be 1 over x squared, with the plus or minus sign in front. So, with that in mind, so I look at the entire function, and I recognize I have something over x in here, and I have something over x squared at the bottom, and that gives me a hint of doing the sub to simplify the problem. If I let u equal to 3 over x, then du is negative 3 over x squared. This is 3 times x to the negative 1, right? Derivative, negative 1, bring it down, so negative 3. X is negative 2, which is 3 over x squared dx. Okay. So this problem becomes what? Integral e to the 3 over x is e to the u, and dx over x squared gonna be negative 1/3 du. Okay. 1 over x squared dx is equal to negative 1/3 du. I divided both sides by 3. Negative 3. Okay, and this is doable. Integral of e to the u is just e to the u, so e to the 3 over x, negative 1/3, and plus c. Okay. So if you see it, it's pretty quick. If not, it's going to take a while. And how do we see it quick? Practice, guys. Just do it over and over. Okay. All right, there's a lot more of those exercises for you guys to practice. And I'll just show you a couple of examples in here. But more, again, I'm sure that's going to be hard. And some problems are going to be hard. So please spend some time, practice the exercises, do as many as you can. If you have any questions, just ask me. Please ask me like right away. And then I can give you a hint to take care of those exercises, okay? As long as you ask, I'll try to give you guys my answer as quick as possible. Thank you for watching, everyone, and have a great week.